Final revision for preparatory 3 first term. Algebra and statistics. Cartesian product of two infinite sets and represent it. If x equals set 1 and 2 and y equals set of 5, 7, 8, then x multiply y if the set of all ordered pairs whose first projection of each of them belongs to x and the second projection of each of them belong to y, then x multiply y equal set of ordered pairs, first one 1 and 5, the second one 1 and 7, and 1 and 8, 2 and 5, 2 and 7, and the last one 2 and 8. To represent it by using arrow diagram, look at here column x and here column y. Set of x 1 and 2 and set of y 5, 7, 8. To represent it graphically, diagram by using graphical diagram or Cartesian diagram, x-axis and y-axis, also element of set of x 1 and 2 and y 5, 7, 8. To represent it, we will join 1 to 5 and 1 to 7 and 1 to 8. Look at here ordered pairs 1 and 5, 1 and 7, and 1 and 8. 1 joined to 5, 1 joined to 7, and 1 joined to 8. The second element here too, we will join to 5 and 7 and 8 also. Ordered pair 2 and 5, 2 and 7, and 2 and 8. By same way, we will represent it by Cartesian diagram. 1 will join with 5, 1 will join with 8, and 1 and 8. Same here in 2, 2 and 5, 2 and 7, and the last one 2 and 8. If we need to find out y multiply x, here x multiply y, then the first coordinate will be 1 and second one will be 2. What about y multiply x? The first coordinate will be 5 and 7 and 8. As shown, is a set of all ordered pairs whose first projection of each of them belong to y and the second projection of each of them belong to x. Then the ordered pair will be y multiplying x, the set of ordered pair 5 with 1 and 5 with 2 and 7 with 1, 7 with 2, and also by same way 8 with 1 and 8 with 2. As shown here, to represent it by arrow diagram, the first column here will be a y and second one will be x. Element of y 5, 7, 8. Join 5 with 1 and 2, 7 with 1 and 2, 8 with 1 and 2. By same way in Cartesian diagram. 5 here will be y-axis and x-axis. 5 will join with 1 and 2, 7 with 1 and 2, 8 with 1 and 2. X multiply x is the set of all ordered pairs whose first projection and second projection belong to x. X multiplied x. 1 with 1 and 1 with 2, 2 with 1 and 2 with 2. To draw it with arrow diagram, two columns will be x and x. 1 will join with 1 and 1 with 2, 2 with 1 and 2 with 2. Different way to arrow diagram. We look here 1 and 2. The first arrow will be 1, 2 itself. The first ordered pair 1 and itself. Represent it by using circle. Then the second ordered pair 1 to 2. Like that. This arrow in this way. The second number is 2. To find out 2 to 1, I will join an arrow from 2 to way to 1 and 2 and 2. Circle in the number 2. To represent it in Cartesian diagram, I will draw two axes, x and x. 1 and 2, 1 and 2. 1 will be 1 and 1, 1 will be 1 and 2, 2 and 1, 2 and 2. Remarks. The first one, x multiply 1 not equal y multiply x, where x not equal y. Number 2, number of x and y equal number of y and x multiply x equal number of x multiply number of y, wherein is the number of elements. Number 3, number of x multiply x equal number of x power 2 equal open bracket n open bracket x close bracket all power 2. And the last remark, x multiplied phi equal phi multiplied x equal phi. The relation and its representing. The relation from the set x to the set y is a connecting, joining some or all the element of x with some or all the element of y. For example, if R is the relation from the set x to the set y, then number 1, R is the set of ordered pairs where the first projection of each belongs to x and the second projection belong to y. R subset x multiplied y. Number 3, the relation can be represented by an arrow diagram or by Cartesian diagram graphically. If R is a relation from x to x, then R is a relation on x and R subset of x multiply x. Example, if x equal 1 and 2 and 3, set of y equal 1, 2, 3, 6, and R is a relation from x to y where A relation B means A is a factor of B. For each A belong to x and B belong to y. Then write R and represent it by an arrow diagram and Cartesian diagram. Solution. Relation will be, open braces, the first ordered pair 1 and 1, and second one 1 and 2, 1 and 3, 1 and 6, and 2 and 2, 2 and 6, 3 and 3, and the last one 3 and 6. What is the meaning of factors of number B? As shown, I will explain how could I answer this question. Draw two columns. The first one will be x and second one will be y. Put element of x in the column of x, 1, 2, and 3. Also put element of y in column of y, 1, 2, 3, and 6. 1 will be factor for all numbers. 1 will be factor for 1 and 2 and 3 and 6. So I will join 1 to all of this. What about 2? 2 will be factors of number 2 itself and number 6. So I will join it to 2 and 6. I will not join, or I can't join it for 1 and 3, because 1 and 3 not factor to 2, or 2 not factors for each of 1 and 3. So I will join it to 2 and 6 only. What about 3? 3 not factor for 1 or 2, but it factor for 3 and 6. So I will join 3 to 3 and 6. To represent it by Cartesian diagram, I will put here x and here y. Element of x 1, 2 and 3. Element of y 1, 2, 3 and 6. 1 with 1, we will put the point here, 1 and 2, 1 and 3, 1 and 6. 2 and 2, 2 and 6. What about 3? 3 will be joined with 3 and 3 and 6. The function. A relation from x to y is said to be a function if each element of the set x appears only once as a first projection in one of the ordered pairs of the relation. Each element of the set x has one and only one arrow going out of it to one element of y in the arrow diagram, which represents the relation. Each vertical line has one and only one point lying on it of the points which represent the relation in the Cartesian diagram, which represents the relation. If is a function from the set x to the set y is written as if to x to y, then x is called the domain of the function f, y is called the codomain of the function f, and the last one, the set of images of the element of the set x by the function f is called the range of the function f, which is a subset of the codomain y. What about taking an example to explain what I had told before? If x equal 1 and 2, 3, y 1, 4, 5, 1, 4, 9, then the following diagrams show some of the relations from x to y, and we note which of the following relation represent a function from x to y and which doesn't represent. The first example, column x and column y. As shown, 1 join to 1 and 2 join to 9, 3 join to 9. So, is this relation or not? As shown, 1 join to 1 and only one number in column of y. Same here and same here. I think this is relation. The second example, x and y. As shown, 1 join to two numbers, or have to raise from x column to y column. 1 join to 1 and 1 join to 4. 2 to 4, 3 to 9. I think it's not function. And the last one, 1 here join to 4 and 3 join to 1 and 2 haven't any arrow to y column. I think also like here, don't function. Notes in the first example. Going out only one arrow from each element of the element of x. then the relation is a function from x to y. The domain will be 1 and 2 and 3. So the domain mean x column and the range mean the number which gone from array from x column to y column, like 1 and 9. Arrow here go from x to y column to 1 and 9. So the range will be 1 and 9. Again, x mean the domain 1 and 2 and 3. The range will be y column, the number which have ray from x to it, like 1 and 9. 1 and 9 are called range, and 1, 2, 3 are called the domain. Here, not going out to arrows from the element 1 to x, going out to arrows, arrow to 1 and arrow to 4. Then the relation is not a function from x to y. And the last one, not 3r, there are not arrows going out from the element 2x. Then the relation is not a function from x to y. The polynomial function. The polynomial function is a function whose rule is term or an algebraic expression in a condition that the following should be identified. Each of the domain and the codomain of the function is the set of real numbers. Number 2, the power, the index of the variable x in any of its terms is a natural number, which noting that the degree of the function is the highest power of the variable x. For example, the function f to f x equals 3 is a polynomial function of 0 degree. Why it 0 degree? Because we don't have here any symbol. We have here only numbers. So its degree will be 0 degree. The function f of x equal to x plus 1 is a polynomial function of the first degree. As shown here, the power of x is 1. So the function of the first degree. And the last one, the function f of x equal x cube minus 5x power 2 plus 1 is a polynomial function of the third degree. So to get out the degree of any function, you should find out the highest term or the highest power in each term. The power here is 3, and here is 2, and here is 0. So the highest power here is third degree. The graphical representation of polynomial function. The constant function. The function f to r where f of x equal b belong to r is represented by a straight line parallel to x-axis and intersects y-axis at the point 0 and b. First example, f to f of x equal to, how to draw it? Like that, x-axis and y-axis. F of x equal to 2 here will be represented on y-axis. As shown, we will draw a straight line passing through the point 2 on y coordinate and parallel to y-axis, x-axis. Again, we will draw a straight line passing through the number 2 and parallel to x-axis. The straight line above x-axis and passing through the point 0 and 2, 0 here mean x-axis and 2 y-axis, is of that 0 degree, because here we have no any symbol, so its power will be 0 degree. Next example, if 2 of x equals 0, we will represent it like that. The straight line will be congruent to or above x-axis and perpendicular to y-axis as shown. The straight line is coincident with x-axis and passes through the point 0 and 0. Here has not degree. The last one, if 2 of x equal negative 3, as shown, we will draw straight line parallel to x-axis and passing through numbers negative 3 and y coordinate or y-axis. The straight line below x-axis and passes through the point 0 and negative 3. As we know, 0 mean x-axis and negative 3 mean y-axis, is of 0 degree. Here and here 0 degree. If we have like here f of x equals 0, it has not degree. The linear function. The function f to r are where f of x equal ax plus b. A belong to r different set of 0. B belong to r is called linear function of the first degree, and is represented by straight line intersects y-axis at 0 and b and x-axis at negative b over a and 0. F2 of x equal to x minus 3. We will substitute x here by 3 numbers or consecutive numbers. We will put the first number will be 0 and second one and the third one will be 2. If we substitute 2x by 0, the first number will be f of x will be, substitute x by 0, 2 multiply 0 equals 0. The result will be negative 3. Substitute x by 1, 2 by 1 equal 2 minus 3 equal negative 1. Substitute 2 by x by 2, 2 by 2 equal 4, 4 minus 3 equal 1. Again, substitute x by 0, the result will be negative 3 f of x. Substitute x by 1, the result will be negative 1. Substitute x by 2, 2 by 2 equal 4 minus 3 equal 1. To represent it, we'll draw first x-axis and y-axis. Represent these ordered pairs here. The first ordered pair 0 and negative 3. 0 here and negative 3. Then this is the first point. Intersect with y-axis at negative 3. The point or the second coordinate 1 and negative 1. 1 here and negative 1 here. This is the second point. And the last one, 2 and 1. 2 here from x-axis, 2, 1 from y-axis, intersect here. And draw a straight line passing through these 3 points to draw this straight line. The straight line L1 intersects x-axis at 1.5 and 0. Y-axis at 0 and negative 3. again the straight line L1 intersects at x-axis at this point 1.5 and y equals 0. 1.5 in x-axis and 0 in y-axis. The ordered pair will be 1.5 and 0. The point which intersect with y-axis here -3 in y-axis and 0 for x-axis. So it will be the ordered pair y-axis at 0 and -3. Second example. If 2 of x equals 3 minus 2x, we'll substitute by using 3 consecutive numbers 0, 1, and 2. Substitute x here by 0, so 3 minus 2 multiplies 0 equals 3 minus 0 equals 3. Substitute x by 1, the result will be 3 minus 2 multiply 1 equals 3 minus 2, the difference will be 1. And the last one, substitute x by 2. The result will be 3 minus 2 multiply 2 equal -1. As shown here, the first coordinate 0 and 3. 0 here and go to 3. Yes, here. And second ordered pair 1 and 1. 1 in x-axis and 1 in y-axis. The second point will be here. And the last ordered pair 2 and -1. 2 in x-axis and here. 2 and -1. Then I will join 3 point, or I will draw a straight line passing through these 3 points and called L2. The straight line L2 intersect x-axis here at a point or ordered pair 1.5 and 0, and at y-axis at 0 and 3, like that. The quadratic function. The function R to R where f of x equal ax power 2 plus bx plus c, where a and b and c belong to R and a not equal 0. It's called a quadratic function, and it is a polynomial function of the second degree, and it is represented by a curve whose vertex is -b over 2a and f of in bracket -v over 2a. The first example for this. F of x equal x power 2 minus 3x plus 2. X belong to interval or closed interval 0 and 3. Like that. We'll draw or make a table like this. X will be 0, 1, 2, and 3. 0, 1, and 0, 1, 2, and 3 goes at closed interval 0 and 3. It means all numbers from 0 to 3, like 0 and 1 and 2 and 3, like that. We'll substitute x here by 0. The result will be 2. How come? X power 2 minus 3x plus 2 will substitute x by 0. It will be 0 power 2 minus 3 multiply 0 plus 2. 0 minus 0 plus 2, the result will be 2. Substitute x by 1. 1 power 2 minus 3 multiply 1 plus 2. It will be 3, 1, and 2, 1. Positive 1, positive 2, positive 3, minus 3. The result will be 0. We'll substitute also x by 2. It will be 2 power 2 minus 3 multiply 2 plus 2. Mean 4 plus 2 equals 6 minus 6. The result will be also 0. And the last one. We'll substitute x by 3. It will be 3 power 2 minus 3 multiply 3 plus 2. The result will be 2, as shown in this graph, Cartesian graph or Cartesian product. Here, x-axis and y-axis. We will represent each ordered pair like that. The first ordered pair will be 0 and 2. 0 and 2. This is the first point. And second one, 1 and 0. 1 in x-axis and 0, so it will be at same place. The third one, 2 and 0. Also 2 in x-axis, and let it as it is in x-axis. And the last one, 3 and 2. 3 in x-axis and 2 in y-axis. The point will be here. Then join these points by your hand to get out this draw. The vertex of the curve here, 3.5 and negative quarter. 3.5 here in x-axis and in y-axis, in y dash, it will be negative quarter, as shown. Drop line segment perpendicular to y-axis to get out negative quarter. Then the vertex of the curve, it will be ordered pair 3.5 and negative quarter. The minimum value of the function. What's the meaning of minimum value? Minimum value, it is the number which intersect at y-axis. As shown, we will drop down a line segment from this vertex to and perpendicular to y-axis to get out it at negative quarter. Then the minimum value of the function will be negative quarter. The equation of line segment, we can get it easily. What is the meaning of the equation of the line of symmetry? The equation, by easy way, will drop down and straight line perpendicular to x-axis and passing through the vertex. Then the intersect in or at x-axis, it will be the equation of the line of symmetry, as shown. Drop down straight line perpendicular to x-axis as a vertex. It will be here, intersect at 3 and 3 or 1.5 or 3/2 at x-axis like that. So the equation of the line of symmetry, it means intersect of straight line which passing through the vertex of the curve intersected with x-axis. Here it will be the equation of the line of symmetry as shown. Next example. If x equal to x minus x power 2, x belong to interval -1 and 3. As shown, we'll substitute x with from -1 till 3 because it closed interval. So the number will be -1, 0, 1, 2, and 3. The next step, we will substitute x here by -1. 2 multiply -1 minus -1 all power 2. By the way, to find out this function or substitution and will be right, you should put any substitution here in bracket. What it mean? I will put 2 open bracket, -1 close bracket, minus open bracket, -1 close bracket, all power 2. To get out, the answer will be -3. The next number We will substitute x here by 0. 2 multiply 0 minus 0 all power 2. The result will be negative 1, 0. And if we substitute x here by 1, f x will be 1 also. Substitute x by 2. 2 multiply 2 minus 2 all power 2. 4 minus 4. The result will be 0. And we will substitute x by 3. 2 multiply 3 equals 6 minus 9. It will be the answer negative 3. To represent it graphically, we will represent each ordered pair here at here. Negative 1 in x-axis here, and negative 3. Negative 1 in x-axis and negative 3. The first point will be here. The second ordered pair 0 and 0. Original point or original point. This is the second point. And the last chord and the third ordered pair here 1 and 1. The point will be here, and the fourth one will be 2 and 0 at x-axis. To here, and the last point will be 3 and negative 3. 3 at x-axis and go to negative 3 here to represent the last ordered pair. Then by using your hand, join these points like this. The vertex of the curve will be 1 and 1. The maximum value of the function 1 equal 1. The maximum value of the function equal 1. As before, here minimum will be negative quarter, and here the maximum will be 1. How could I find out the maximum value of the function? From this vertex, drop perpendicular from it to y-axis like that. From here, drop line segment to y-axis to find out the number which intersected with the perpendicular. The number will be 1. The equation of line of symmetry. We will drop down straight line from vertex of this curve passing through x-axis and perpendicular to it at 1. Then the equation of line of symmetry, x equal 1. The ratio and its properties. The ratio between the two real numbers a and b is written as a to b or a over b, and a is called as antecedent of the ratio, b is called an consequent, and a and b are called the two terms of the ratio. The value of the ratio doesn't change if each term is multiplied or divided by the same non-zero real number. The value of the ratio change if we add or subtract to or from each of its two terms the same non-zero real number. If the ratio between two numbers is a and a to b, then the first number equal am and the second number equal bm. M not equal 0. For example, two numbers, their sum is 28 and the ratio between them is 3 to 4. What are the two numbers? Solution. Let the two numbers be 3m and 4m. As shown, the ratio 3 to 4. So let the two numbers be 3m and 4m. Therefore 3m plus 4m equal 28. Therefore 7m equal 28. Therefore m equal 28 over 7. The quotient will be 4. Therefore the two numbers are 3 multiplied 4 and 4 multiplied 4, i.e. 12 and 16. Then the two numbers will be 12 and 16. The proportion and its properties. The proportion is the equality of two ratios or more. For example, if A over B equals C over D, then A, B and C and D are proportional quantities. If A and B and C and D are proportional quantities, then A over B equals C over D. Property 1. If A over B equals 3 C over D, if we make scissors here, then A multiply D equal B multiply C. Therefore 3 over 4 equal 27 over x. By using scissors here, the product of extremes equal product of the means. For example, find the first proportional of the quantities 3, 4 and 27. Again, find the first proportional of the quantities 3, 4 and 27. Solution. Let the first proportional be x. Therefore, the quantities will be 3, 4, 27 and x are proportional. Then the first over second equals third over fourth. 3 over 4 equal 27 over x. Use scissors here. We will multiply 3 multiply x and 4 multiply 27. So will be the product here 3 multiply x equal 4 multiply 27. Therefore x equal 4 multiply 27 over 3. X will be 36. The fourth proportional equal 36. Property 2. If A multiply B equal B multiply C, then if we multiply A by B and if we divide A by B, A over B equal C over D. Again, if A multiply D equal B multiply C, then A divided B equal C divided D, like this. A over B equal C over D. If we use scissors here, it will be back again. Scissors A multiply D like this, B multiply C like this. Also, each of the following properties is correct. A over C equal B over D, D over B equal C over A, B over A equal D over C. For example, if x plus 3y over 2x minus y equal 4 over 3, then find the ratio x to y. Solution. Since x plus 3y over 2x minus y equal 4 over 3, therefore, if we use scissors here, 3 open bracket x plus 3y equal 4 open bracket 2x minus y. Therefore 3x we will use here and here, distribute, multiply over addition. 3 will be multiplied with x and also with 3y. 3x plus 3 multiplied multiply 3 equal 9y equal 4 multiply 2x 8x minus 4 multiply y will be 4y. Therefore 13y equal 5x. Therefore x to y equal 13 to 5. Property 3. If a over b equals c over d, then a over c equal b over d. It means the antecedent of the first ratio over antecedent of the second ratio equals the consequent of the first ratio over the consequent of the second ratio. Again, if a over b equals c over d, then numerator here will be divided by numerator here, a divided 3 equal b divided d. Again, a divided c equal b divided d. For example, if a over 4 equal b over 3, then a over b equal 4 over 3, or b over a equal 3 over 4. Property 4. If a over b equal c over d, then a equal cm, b equal dm, where m is a constant. A will be cm and b will be dm. For example, if a to b equals 3 to 5, then find the ratio 20a minus 7b to 15a plus b. Solution. Since a over b equals 3 over 5, therefore a equals 3m, b equal 5m, where m not equal 0. Again, since a over b equals 3 over 5, it will be a equals 3m, b equal 5m. Substituting by a and b in term of m. Therefore, 20a minus 7b, here 20a minus 7b over 15a plus b. Substitute a here by 3m and b by 5m, like this, equal 20 by 3m will be, the product will be 60m, minus 7 by b, we will substitute b here, take out b and substitute it by 5m. 7 by 5 equals 35m over 15 multiplies 3m equal 45m plus b, substitute it by 5m, like that. The result will be 25m over 50m. We will cancel m with m. The quotient will be half or 1 over 2. The concept of the symbol and the method of collecting it. The symbol. It is a small part from large society that looks like the society and represent it well. The method of collecting the symbol and its types. The first type, base selection. Second one, randomly selection. What about base selection? Oh yeah. The type of the symbol, not a random symbol, deliberate symbol. Its usage, it is used to select the individual of the symbol in a way to satisfy the objective of the research. Randomly selection. The type of the symbol, random symbol, its usage, it's used for the homogeneous societies which are not naturally divided into groups or classes. The type of the symbol, linear random symbol. The number of individual of the layer in the symbol equals the total number of individual in the layer over the total number of individual in the society by the number of individual of the symbol. Approximated the result of the nearest unit. We'll take an example to explain it clearly. For example, at a faculty there are 4,000 university students in the first grade, 3,000 in the second grade, and 2,000 in the third grade, and 1,000 in the fourth grade. If we want to draw a layer symbol of 500 students, where each layer or layer is represented in this symbol according to its size, calculate the number of students in each layer in that symbol. Solution. The total number of students equal 4,000 plus 3,000 plus 2,000 plus 1,000. The sum will be 10,000 students. The number of individual of the first layer in the symbol equal the first layer in the symbol. The first one will be 4,000 over total multiply 500. It's easy. Again, first layer in the symbol 4,000 over the total student, 4,000 over total students, 10,000 multiply 500. The product will be 200 students. The number of individual of the second layer in the symbol equals 3,000 over the total, also 10,000 multiply 500. The product will be 150 students. The number of individual of the third layer in the symbol equal 2,000 over 10,000 multiply 500. The product will be 100 students. The number of individual of the fourth layer in the symbol 1,000 over 10,000 multiply 500 equal 50 students. The dispersion and its measurement. The dispersion. It is a measure that expresses how much sets are homogeneous. Dispersion measurement. The first way. The range is the simplest measure of dispersion. It is the difference between the greatest value and the smallest value in the set. It means the range equals the greatest value minus the smallest value. For example, the values of set X are 55, 53, 57, 56, and 54. To find out the range, we search the greatest value here. The greatest value will be 57 minus the smallest value is 53. The difference will be the range. 57 minus 53, the difference will be 4. 4 is the range here. Example, the value of set Y are 67, 73, 41, 60, 34, then the range equal. Where here the greatest value, it will be 73, and the smallest value will be 34. The difference between 73 and 34, the difference will be 39. So the set Y is more divergent than the set X. Number 2, standard deviation. Oh yeah. The standard deviation of the set of values. And the standard deviation of frequency distribution. First example, for standard division of set of values 55, 53, 57, 56, and 54. The standard deviation rule is sigma equal root summation open bracket x minus x bar all power 2 over n. X denotes a value of the values 55, 53, 57, 56, 54. All of these are x. X bar denotes the mean of the values. To find out the mean, we will add all of these over its number. Rule of mean equals sum of values over number of values. So I will add 55 and 53, 57, 56 and 54 and divide it by 1, 2, 3, 4, 5. The rule again of mean of values. Sum of values over number of values. N here denotes the number of values. 1, 2, 3, 4 and 5. Summation denotes the summation operation. The second type, the standard deviation of frequency distribution. The wage, number of person, 20 over 2, 25 over 3, 30 over 5, 35 over 5, 40 over 1, 45 over 4, total over 20. The standard division, the rule here different from here. Standard division equal root summation x minus x bar all power 2 k over sum of k. K here mean x represents the value of the center of the set. K represents the frequency of the values of set. Here, all of these numbers represented by k. And here x. Sum of k is the sum of frequency. Total here will be 20. X bar the mean. The rule of mean here equals summation. X multiply k over sum of k. To explain this two types, we have to take some examples. The first example. Calculate the standard division of the values 55, 53, 57, 56, and 54. As shown before, solution. We find the mean of values x bar equals sum of k, sum of x over n. Sum of x over n. Like that. 55 plus 53 plus 57 plus 56 plus 54 over number of values 5, the quotient will be 55. We form the opposite table as shown. The first column is x and the second one x minus x bar and third one x minus x bar all power 2. We will put all elements of these or these values in x column. 55, 53, 57, 56, and 54. The second column, the difference between x and x bar. X here 55 minus x bar, which represent mean 55. 55 minus 55, the difference will be 0. 53 minus 55 will be negative 2. 57 minus 55 equal 2. 56 minus 55 equal 1. 54 minus 55, the difference will be negative 1. X minus x bar all power 2. We will put 0 all power 2. 0 all power 2 will be 0. Negative 2. By the way, you should put any number here between two brackets. Negative 2 all bracket. Negative open bracket, negative 2 close bracket, all power 2 to find out 4. 2 all power 2 will be 4. 1 all power 2 will be 1, negative 1. Between two brackets, you must put negative 1 between bracket before put power 2. So it will be open bracket negative 1 close bracket all power 2. The result will be 1. Find out the sum of these numbers to get the total here will be 10. We calculate standard devision by substituting in the law. The standard division equal root summation x minus x bar all power 2 over n equal root 10 over 5 equal root 2 equal 1.4. Another example. The following table shows the distribution of wages of 20 persons in bounds. As shown, find the standard deviation of the wages. Solution. We find the mean of the wages x bar by using the opposite table. Example. The following table shows the distribution of wages of 20 persons in pounds. Find the standard division of the wages. Solution. First step, we find the mean of the wages x bar by using the opposite table. As shown, the wage x, number of person k, and x multiply k. In the first column of the wages of x, as shown here, all numbers above here put here. So x column represents the wages and k column represent number of persons as shown, and the column here the multiply or the product of both of them. 20 by 2 equal 40, 25 by 3 equal 75, 30 by 5 equal 150, 35 by 5 equal 175, 40 by 1 equal 40, 45 by 4 equal 180. The total here equals 660. Total of our sum of x multiply k and the number of persons, sum of number of person or sum of k equal 20%. Then the mean x bar equal summation of x multiply k over summation of k. We will substitute for summation of product of x and k here 660 and summation of k 20. Then the quotient will be 33 pound. Then the mean x bar equals 33 pound. The next step or the second step, we form the opposite table as shown. X k x minus x bar all power 2 x minus x bar all power 2 multiply k. As shown here, x column the number of x, all of number of x put here in this column, and number of k, numbers of k put here in k, and x minus x bar. We will add this column and also this. X minus x bar will be 20 minus 33. 33 here represent x bar or represent mean, which we get before. 33 here will be subtracted from each element of x. 20 minus 33, the difference will be negative 13, and so on here. X minus x bar all power 2. We will multiply or find out bracket here negative 13 here bracket close bracket all power 2. The result will be 169, and here put bracket open bracket negative 8 close bracket all power 2 will be 64 open bracket negative 3 close bracket all power 2 equal 9, 2 equal 4, 7 equal 49, 12 equal 144. The sum here, or the next column, x minus x bar all power 2 multiply k. This number, I will multiply it by this number. X minus x bar all power 2 column will multiply with k column. 2 multiply 169, the product will be 338. 3 multiply 64, the product will be 192, and so on. The summation here 1220. Third step, we calculate the standard deviation from the law. The standard deviation sigma equal root summation x minus x bar all power 2 multiply k over sum of k equal root 1220 over 20. The result will be 7.8 pounds. So the standard deviation here equals 7.8 pounds. Second example. The following is the frequency distribution of weekly incentive of 100 workers in a factory. Find the standard deviation of this distribution. Solution. First step, we find the mean x bar by using the following table. Note, the center of the set equal lower limit plus upper limit over 2. I will explain it clearly now. As shown in this table, this column this column represents sets. This column represents center of the set x, frequency or k, and here product of k and x. First set 35, 45, 55, 65, 75, and 85. Center of the set x, this number which represents this table 35, 45, 55, 65, and 75. To cancel this dash, I will use this property. I will add this number to the following number, or lower limit plus upper limit divided 2. I will add this number and then divide it by 2. 35 plus 45, the sum will be 80. 80 divided 2 will be 40. 45 plus 55 will be 100. 100 divided 2 will be 50. This number I will add with the second one. 55 plus 65, the sum will be 120. 120 divided 2 will be 60. Also 65 plus 75, the sum will be 140. 140 divided 2 will be 70. 75 plus 85 will be 160. 160 divided 2, it will be 90. 85 plus the next number, it will be 95, will be 180 divided 2, it will be divided 2 will be, the result will be 90. Then I will use this column and I will cancel it, and I will use it this column x and this column k. This column product of both of them, 40 by 10 equal 400, 50 by 14 equal 700, 60 by 20 equal 1200, 70 by 28 equal 1960, 80 by 20 equal 160, 1600, 90 by 8 equals 720. The total here will be 6580, and this total here will be 100 as shown here and here. Therefore, the mean x bar equals summation of x, the product of x and k over summation of k, equal summation of product of x and k will be 6580 as shown, and summation of frequency x frequency k equal 100. The quotient here equals 65.8 pound. The second step, we form the following table as shown: x, k, x minus x bar, x minus x bar all power 2, x minus x bar all power 2 multiply k, and put the element of x as shown and numbers of k as shown. Then I will subtract the mean from each value from x column as shown. 40 minus 65.8, 65.8 here represent the mean x bar. The difference will be negative 25.8 and so on. The next column I will find out this number all power 2 as shown. Open bracket negative 25.8 close bracket all power 2. The result will be 665.64 and so on. Here the last column will be x minus x bar all power 2 multiply k. I will multiply this column with k column. These values, I will multiply these values with these values. 10 multiply 665.64 equal 6656.4 and so on, to get out the summation of these, of the product of these, 20,036. Third step, we calculate the standard deviation by using the law. Standard deviation sigma equal root summation x minus x bar all power 2 multiply k over summation of k equal root to 20,036 divided 100. The result will be 14.15 pound. Notes: the values which are more homogeneous have less dispersion and their standard deviation is small. The last note: if the standard deviation equals 0, that means the all values are equal. It is the perfect homogeneous case, the vanished dispersion. Geometry. The main trigonometrical ratio of the acute angle and the important relation between them. The trigonometrical ratio of the angle A. We have here right angle triangle at B. To find out sine A or cosine A or tan A. Sine A equal opposite over hypotenuse equal BC over AC. Cosine A adjacent over hypotenuse. Adjacent here AB over hypotenuse AC. Tan A equal opposite over adjacent. Opposite here BC and adjacent is AB. The trigonometrical ratio of the angle C. The angle C here. Sine C equal opposite over hypotenuse. Opposite will be AB and hypotenuse AC. Cosine C equal adjacent over hypotenuse. Adjacent here will be BC over hypotenuse AC. Tan C equal opposite over adjacent. Opposite here AB over adjacent BC. Some important relations. Tan A equals sine A over cosine A. If measure of angle A plus measure of angle C equal 90, then sine A equal cosine C and cosine A equal sine C. If sine A equal cosine C or cosine A equal sine C, then measure of angle A plus measure of angle C equal 90 degree. Trigonometrical ratio of some angles. We have triangle like that, and we have angle 30. To find out sine and cosine and tan 30, sine 30 equal half, opposite over hypotenuse. Cosine 30 equal square root 3 over 2, adjacent over hypotenuse. And tan 30 equal 1 over 3, 1 over root 3, opposite over adjacent. To find out sine 60, cosine 60, and tan 60. Sine 60 will be square root 3 over 2, cosine 60 will be half, and tan 60 will be root 3. To find out sine 45, cosine 45, and tan 45. Sine 45 will be 1 over square root 2. Cosine 45 will be 1 over root 2. Tan 45 will be 1. Remark. If cosine theta equals 0.7152, then we use the calculator to find theta by using the keys as the following sequence from left. Shift cosine 0.7152 equal and this number. Then theta equal 45 degree, 20 minutes, and 25 seconds. The important laws. We have A here, which have ordered pair x1, y1, and B x2, y2. The law of the distance between the 2 points A and B. The length of AB. To find out the distance between 2 points or the length of this point, we should use this law. AB equal root, open bracket, difference x coordinate all power 2 plus difference y coordinate all power 2. The law of finding the coordinate of the midpoint of AB. To find out the midpoint of any line segment, you should use this law. The midpoint of AB equal x1 plus x2 over 2, and the second projection will be y1 plus y2 over 2. The third law, the law of finding the slope of the straight line AB. To find out the slope by using coordinates, you should use this law. M equal y2 minus y1 over x2 minus x1. How to find the slope of the straight line? The first law. If you have 2 points on the line as a x1, y1, bx2 y2. To find out slope from these points or this coordinate, you should use this law. M equal y2 minus y1 over x2 minus x1. Second method. Given the measure of the positive angle which the straight line makes with the positive direction of x-axis, say theta, m equal tan theta. The third way, given the equation of the straight line in the form y equal bx plus c, to find out slope from this equation, you should use this law. M equal b, where b is the coefficient of x. Mean b here represent the slope. Given the equation of the straight line in the form ax plus by plus c equals 0, the slope here negative coefficient of x over coefficient of y equal negative a over b. We notice here and here the difference between two equations. The equation here, y in left hand and x in right hand. The slope here will be b, direct. But here the equation ax plus by plus c equals 0, both of x and y in same way or in same hand, left hand side. So we will use different law which represent by m equal negative coefficient of x over coefficient of y equal negative a over b. Number 5, given the slope of parallel straight line to it, say m1, we use this law. M equal m1 because the two slopes are equal. And the last one, given the slope of the perpendicular straight line to it, say m2, we use this with this law. M equal negative 1 over m2 because m multiply m2 equal negative 1. The remarks on the slope of straight line. First one, if L equal or L parallel to x-axis, the slope of x-axis equals 0. The slope of the straight line parallel to x-axis equal 0. So, if we have here straight line parallel to x-axis, it means the slope equal 0. And second one, if we have here L perpendicular to x-axis, the slope of y-axis is undefined. The slope of the straight line parallel to y-axis is undefined because here we have no slope. Yep. Again, if straight line parallel to x-axis, the slope equals 0, and if it perpendicular to x-axis, the slope undefined. We have here straight line L intersect with x-axis and y-axis as shown. Theta here acute angle, positive direction of x-axis. The slope of straight line which makes an acute angle with the positive direction of x-axis is positive. The slope here will be positive. About here, obtuse angle with positive direction of x-axis. The slope of straight line which make an obtuse angle with positive direction of x-axis is negative. Again, if the angle which make from intersecting straight line L with x-axis, if it make acute angle, the slope will be positive. Here, if the angle which make from intersecting the straight line L which intersect with x-axis is make obtuse angle, then the slope will be negative. Acute will be positive, obtuse slope will be negative. The two parallel straight lines, their slope are equal. Mean if L1 parallel to L2, then slope of L1, which represented by M1, equal the slope of L2, which represented by M2. If L1 perpendicular to L2, the two perpendicular straight line, the product of their slopes equal -1. It means if L1 perpendicular to L2, then M1 multiply M2, the product will be -1. Again, if two straight lines are parallel, then slope. What's wrong? What's wrong? Oh shit. Again, if straight line L1 parallel to straight line L2, then the slope M1 equals slope M2. And the second type, if L1 perpendicular to L2, then the product of slope, first slope and second slope equal -1. The equation of the straight line. The equation of straight line whose slope M and cuts y-axis at the point 0 and C is y equal mx plus c. For example, the equation of straight line whose slope is -2 and cut from the positive part of y-axis 7 units will be y equal -2x plus 7. -2x here represent slope and 7 here represent the part of or the number which straight line cuts it in y-axis, presented here by 7. Then the equation will be y equal -2x plus 7. Find the equation of straight line whose slope is 3 and passing through the point 1 and -2. Since the slope equals 3, therefore the equation of the straight line is y equals 3x plus c. Then substitute by the point 1 and -2 to find the value of c as the following. We'll substitute here y by -2 and x by 1 will be -2 and equal 3 multiply substitute x by 1, 3 by 1 plus c. I will substitute here by x and y to find out value of c. Then c equal -5. Therefore the equation straight line is y equal 3x minus 5. Remark on the equation of straight line. The first remark: the equation of straight line which passes through the origin point 0 will be there on 0 is y equal mx, where m is slope. The second remark: The equation of x-axis is y equal 0. The equation of y-axis is x equal 0. Again, the equation of x-axis is y equal 0. And the equation of y-axis is x equal 0. I will explain this remark in the following example. The equation here, remark number 3. The equation of straight line is parallel to x-axis and cuts a y-axis at the point 0 and c is y equal c. The next remark, the equation of straight line parallel to y-axis and cut x-axis at the point a and 0 is x equal a. Very important rules. To prove that the point A, B, and C are collinear, we will prove that the slope of AB equals slope of BC. Slope of AB equals slope of BC. Or AB plus BC equal AC, where AC is the greatest length. Second rule, to prove that the point A, B, and C are vertices of a triangle, we will prove that the slope of AB not equal the slope of BC, or AB plus BC, AB plus BC greater than AC is the greatest, where AC is the greatest length. Number 3, to determine the type of triangle ABC according to its angle measures, we compare between AC all power 2, AB all power 2 plus BC all power 2, where AC is the longest side F. First case here, if we have here AC all power 2 smaller than the sum of the square of AB power 2 plus BC all power 2, then triangle ABC is acute angled triangle. Next case, if we have AC all power 2 equal AB power 2 plus BC power 2, then triangle is right angled triangle at B. The last case, if we find out AC all power 2 greater than AB all power 2 plus BC all power 2, then triangle ABC is obtuse angled at B. Again, first case, if we have the sum of square of two sides greater than the third or greater than the square of third one, we have here acute angle, angled triangle. And if we have here square of sides equals the sum of square to the sides of triangle, we have here right angled at B. And the last case here, if we have side power 2 greater than the sum of power or the sum of square of two sides, we have here obtuse angled triangle. Number 4, to prove that the quadrilateral ABCD is a trapezium, like that, we will prove that the slope of AD equal the slope of BC, then AD will be parallel to BC. The next step, the slope of AB not equal the slope of DC, then AB not parallel to DC. Number Number 5, to prove that the quadrilateral ABCD is parallelogram, like that. By using the slope, we prove that the slope of AD equals slope of BC, then AD parallel to BC. The next step, the slope of AB equal to the slope of DC, then AB equal to DC. Next way, or another solution, by using the distance between 2 points, we prove that the length of AD equals the length of BC, and the length of AB equals the length of DC, then ABCD are parallelogram. Oh yeah. The third way to prove that ABCD is a parallelogram. By using the coordinates of midpoint of line segment, we prove that the coordinates of the midpoint of AC is the coordinate of the midpoint of BD, then AC and BD bisect each other. So we have here 3 ways to prove that ABCD are parallelogram. Use the easiest one for you, then prove it. Number 6, to prove that the quadrilateral ABCD is a rectangle, like that. The first way, by using the distance between 2 points, we prove that the length of AD equals the length of BC, and the length of AB equals the length of DC. Then prove that AC equal BD by using the distance between 2 points. Then we have here ABCD, a rectangle. Or the slope of AB multiply slope of BC equal -1, then AB perpendicular to BC. Number 7, to prove that the quadrilateral ABCD is a rhombus, like that. By using the distance between 2 points, we prove that the length of AD equals the length of BC, the length of AB equals the length of DC. Then prove that AB equal BC by using the distance between 2 points. We have here rhombus ABCD. Or the slope of AC multiply the slope of BD equal -1, then AC perpendicular to BD. We can prove the quadrilateral ABCD is a rhombus directly by using the distance. We prove that AB equal BC equal CD equal DA. This is next way, or another way to find out or prove that ABCD are rhombus. Again, the last way. To prove that ABCD is a rhombus, we prove that by using the distance between points AB equal BC and BC equal CD equal DA. Mean 4 sides are equal in length. Number 8, to prove that the quadrilateral ABCD is a square, like that. We prove that AB equal BC equal CD equal DA. Then the quadrilateral is rhombus. To prove that it will be square, prove that AC equal BD. Number 9, to prove that the point ABC lie on one circle of center M. like that. By using the distance between two points, we prove that MB equal MC equal ME. All radii are equal lengths. Goodbye and good luck. Mr. Tadros.